You can all hear me okay? Yes? Okay. So the overseas trade fostered by the East India companies and other chartered companies introduces innovation and change to the European textile industry during the 17th and 18th century. So indigenous dye materials to Europe, like madder, woad, and weld, are replaced or supplemented by Asian and American dye materials like cochineal, indigo, and quercitron. And of these, cochineal is one of the most popular. When mordanted with the chloride of tin, it's able to dye this very vibrant red, and this found favor across Europe and beyond. And what we find is that the cochineal, this scarlet color, is one of the few points of appeal for British woolens being sold to China in the 18th and 19th century. And this is something I'm writing a book about at the moment. So after decades of effort, the supercargoes in Canton are able to establish scarlet woolens as popular textiles that can achieve higher prices, used by Chinese consumers for hangings and fashionable robes. And we see the popularity of scarlet red very early on. So these are a few price records. For example, in 1672, the merchants, they're actually negotiating with the King of Tongjing in North Vietnam to sell their English woolens. And for broadcloth, the king offers 11 liang for fourth quality green, but he offers 30 for first quality scarlet. In 1722, they sell the entire stock of 4 ships with coarse broadcloth at 0.78 liang per yard, fine broadcloth at 1.8 liang per yard, but the scarlet is 3 liang per yard. And then in 1819, you can see that these prices, the scarlet is being sold for $24 compared to, say, black at $8. So there's a very substantial price difference. And you can also see this in the indents. So these are the orders that the supercargoes send home to London for the woolen orders for the following season. And you can see that scarlet is the third most important color after the obviously very reliable black and blue. We also see the popularity of scarlet in extant objects. So these are some examples of surviving objects of Chinese objects that have been made from British woolens. And as you can see, they're all scarlet. And in fact, most of the objects that I've been able to study are scarlet. And there's obviously issues here in terms of, kind of survival bias and what gets preserved and handed down. But still, I think the fact that so much of it is scarlet is very significant. However, scarlet is also a very expensive color. It's one largely reliant on Mexican cochineal, which is controlled by a Spanish colonial monopoly. And so, during the early 19th century, the East India Company embarked on product research to develop a substitute in the form of lac dye. And this, as we've heard, is a product that's long known in Southeast Asia for various purposes, including dyeing. Like cochineal, lac dye is derived from a scale insect, the Keria lacca, which lives on various trees native to Southeast Asia. But the process of dyeing with lac dye was fraught with technical difficulties. And the developmental process that the East India Company embark on, I think, has 2 important and somewhat overlooked ideas. So one of them is the ways in which the East India Company uses and has access to a global network of dyers, merchants, and chemists, and accordingly, their kind of role as a center or a constellating force for research and innovation. And the other thing I think this story has to tell us is the way in which these export markets, and the Chinese market specifically, and the demand stimulus of Chinese consumers provided a kind of test ground for technical innovation. So, as you've heard, lac dye is known in Europe from fairly on, but we see knowledge about it at a kind of technical and biological level start to be discussed by British chemists towards the end of the 18th century. So the Scottish surgeon James Kerr, who's based in India in this time, gives an account to the Royal Society, and he's the first one to describe the insect as Coccus lacca. You have a second account of a lac insect also given to the Royal Society by Mr. Robert Saunders. But perhaps most importantly, Dr. Roxburgh, who's been described as the founding father of Indian botany, describes various methods for extracting the colouring matter in Kermes lacquer, which is published in 1791. And he's the first to suggest that a method could be found for making lac dye. Actually, I should probably be careful about saying the first after the paper we've just heard. But anyway, he's one of the first to suggest that a method could be found for making lac dye as useful and valuable as cochineal. And he recommends that Ello's process of extracting the dye from dry lac. So dry lac is, when it reaches Europe. So this method should be tried on fresh lac. So he makes this suggestion, and people are really starting to get excited about the possibilities of lac dye compared to cochineal, because it will be so much lower in cost, and also that you could combine it with cochineal. But first they have to extract the colouring matter. So lac is made up, as we've heard, of a resin, a pigment, and a wax. And these three different components are extracted through three stages. So you have stick lac, which is the natural state of the insects upon the twigs. When it's removed from the trees, it's broken into these short lengths and then placed in the sun to dry the insect. Then you have seed lac, where the cells are separated and pounded, and the colouring matter can be extracted by water. And then you have shellac when it's strained and allowed to harden into these transparent laminae. And my fun fact for today, for anyone who likes to have their nails done, is shellac is what they put on their nails. And it's actually horrific now and involves, huge farms of lac insects, and it's probably very bad for the environment, but we'll put that to one side for now. So the East India Company initially export the stick lac, but they find that the colouring matter, although it's more durable in some respects than cochineal, it's not so lively and beautiful. And there are also various issues with solubility when it's being precipitated with alum. And so starting around 1796, you see this global network of dyers, chemists, and merchants embark on this multi-year process to resolve this issue. And much of what we know about this comes from the writings of Edward Bancroft, who is a rather colourful figure, and that pun was definitely most intended. He's born in Massachusetts in 1744. His career spans a naturalist in Guyana, a diplomat and spy on both sides in Paris during the American Revolution period, and then he is an importer and philosophical chemist in London in the post-revolutionary period. And he first comes to prominence in the transatlantic dye-stuff trade in 1775 because he introduces quercitron to England. Quercitron is a yellow dye that comes from the American black oak, and it's used, among other things, to create an imitation yellow color to produce a British version of the Chinese Nankin cotton cloth, which is a naturally occurring color, so it's quite ironic. Anyway, Bancroft discovers this property in 1771, and he actually gets a patent on its usage, which is going to be very lucrative for him. And in 1773, he gets a fellowship from the Royal Society, and we've seen the Royal Society as a very important institution here. And this, together with his work on calico printing, probably brings him to the attention of the East India Company, and they consider him an expert. So he publishes his experimental researches in 1794, and then it's much expanded in 1813, and that's the edition that I've been working with, and that's the edition where he reports on his efforts with lac dye. So this process is quite complicated and involves many different people, and I am slightly jet lagged, so I apologize in advance if anything goes wrong. But Bancroft's involvement seems to be through a collaboration with a surgeon in Bengal in India. So Mr. Stevens, who is an East India Company surgeon in Kirpoi, is the one who first follows Dr. Roxburgh's suggestion of preparing the colouring matter. And he describes this process in a letter to the Court of Directors that's written from the Board of Trade in Bengal, dated to 1796. And it says that the idea was developed through a hint from Dr. Bancroft. Fleming suggests forwarding the samples that he's prepared, together with papers, to Bancroft, and the East India Company Committee of Warehouses do this in 1797, and they request to Bancroft that he informs them of the results, especially, and I quote, how far it might be advisable to import any quantity, and to what extent such importation might be carried, and what might be its relative value compared with cochineal. Now, according to Bancroft, this is the origin of the manufacture of lacklake, which represents a shift in form into cakes like those of indigo. So indigo would have been imported in cakes. And this is apparently how lacklake starts to be brought to this country, and to this country being Britain, in large quantities. And lacklake seems to be manufactured from stick lake by precipitating it from alkaline lixivium, and this is being manufactured in Calcutta. So Bancroft is writing in 1813, and by this point, the lacklakes had been brought back to this country in some volume. However, life and chemistry being complicated, there were issues. So Bancroft writes that the cakes are being prepared by different people, and so the quality varies a great deal, and the coloring matter was quite deteriorated, or could be deteriorated. And so after a period of selling to profit, the purchases ceased, even when the price is quartered, and by 1810, according to Bancroft, the Scarlet dyers are generally determined to abstain from using it. One of the things we're seeing here, and we'll return to this, is that the dyers, and you can think of the dyers in some respects as being an end consumer, were a fairly conservative force. They're often anxious to protect their expertise and maintain the status quo. And so the lacklake preparation is being left unemployed, and this prompts Bancroft to embark on a series of experiments in 1812. So he's confronting kind of two problems. One is this idea of how to extract the coloring matter. There's also a problem that he wants to persuade other chemists, skeptical chemists like Helot or Berthollet, that lac dye is not just durable, but also equally vivacious. This is all about being vivacious in color. So he prepares these samples in 1811 of very fine scarlets using the common dyer's spirit, and he refers them to the committee for buying. In response, they ask him to dye a piece of long ells. So a long ell was the woolen fabric that was most popular in the Chinese market. And so in January 1812, Bancroft goes to Barchard & Co. in Wandsworth, who are the dye house that apparently dye many of this company's scarlet cloths. And he produces these cloths in front of these very competent judges, and they approve wholeheartedly, as do the committee. So he's established this, he's kind of proved that lac dye can be equally vivacious. But soon after this, you get another lac making an appearance. And this one is prepared by a Mr. David Turnbull, who's a surgeon in Bengal. He'd been appointed an assistant surgeon in 1791 and posted to Mirzapur. And there he engages in trade, in country trade goods, so things like indigo. And in 1806, he discovers a new dye, which he calls lac dye. So these are different versions of, based on the lac insect. Now, slightly mysteriously, according to Bancroft, this preparation is not imported for another 5 years until after Bancroft writes to the Court of Directors, reporting back on his experiments and basically saying, you can use lac dye and it can be substituted for cochineal. And then very, very soon after this, the Committee for Buying decide to distribute this lac dye among the company's dyers at a moderate price to be employed in dyeing their cloths, and also to use the lac lake for the same purposes. So basically, Bancroft has kind of proved to the East India Company that both these dye substances can be used. And so the committee apparently obtains from the dyers a reduction in price that saves them, over the course of just 4 months, £14,000. So, it's a big saving. However, the efforts do not cease, and there's two more that I want to discuss. Both of them are failures, but I still think they're quite interesting. So you have another surgeon, Mr. John MacLeod in Madras, who in 1822 produces samples of cloth dyed with a new lac dye, which he sends to the company asking if he should keep preparing. They report back saying, well, we've tried your lac dye, with our dyer, and unfortunately it hasn't worked. It's inferior, it's not as good as Mr. McLeod's, and it's also not as good as Cochineal, and so they turned down his contract. But still, I think the fact that he's still trying in 1822, that he has, he sees this as he sees a potential, I think, is interesting. And there's one more individual I'd like to share with you, and this is someone back in Britain. This is John Parish of Somerset. And I find him completely fascinating. He writes these letters, which are now in the Royal Society, recounting his several years of investigation into lac dye. He had been a dyer for more than 5 decades, and he's quite elderly, he's not in great health, but he's describing this process which is totally imbued in these 18th and 19th century networks of natural scientists. So he begins investigating in 1797 after Captain Carruthers of the H. Dundas Indiaman brings him a sample from India. He's not successful, but he gets another sample from a friend at East India House. And he's working his way through these chests of lac dye, trying to make this viable. And then Sir Francis Baring, who is a director of the East India Company, writes to him inquiring on progress and wondering if it could become a viable import for the East India Company. And he writes back and he reports that he's hopeful, but he still doesn't have much, he hasn't been able to develop a technique with much precision. And he's continuing to work through these chests, and he's continuing to write letters to the East India Company. And then he goes up to London and he finds all his letters and all the reports on his experiments are completely being ignored by the East India Company. They're in a different office and no one's paying attention to him. And then he writes of how the dyer that the dye house that he's working with has also abandoned the project. And he sees this, he describes how even though his secret that that he's discovered possesses the greatest advantage to the scarlet trade, because cochineal had for so long been, and I quote, an inimitable dye, a substitute is hardly conceived possible, and consequently prejudice will have a long ascendant. So Parish, like Bancroft, is facing this kind of conservative inertia. And, we heard before that the dyers were often at the front end of innovation, but I think for the dye houses that produced for the East India Company, they had a lot invested in maintaining things the way they were. And so they had, they opposed it. Parish is also a little bit paranoid about this for various reasons. He suspects the House of Goodwin, who are another East India Company dye house, of stealing his ideas. But what I think is most fascinating about Parish is the way in which his account really positions the East India Company centrally in this very delicate dance between scientific progress and dyeing knowledge. And he shows how the East India Company benefit from the efforts of what appear to be entirely unpaid individuals working for the benefit of the country and them. Bancroft appears to have had no remuneration. He hints at a couple of times to the East India Company that they should really give him something, but none seems to be forthcoming. Parish seems to be just concerned with how to produce beauty and uniformity in a greater degree. And he's also concerned about the kind of bridging the gap between chemical authors and practical dyers. Even Turnbull, who seems to be the most successful in developing an actually viable import product, seems to have profited little. He rather mysteriously is demoted back to assistant surgeon in 1813, just after his product is being exported, and he stays in Mirzapur for the rest of his life. But the East India Company is able to utilize the contributions of these individuals, this network of dyers, merchants, and chemists, and this ultimately makes them at the center of research and innovation in this period. But they need a test ground for these technical innovations, and here Canton and the Chinese consumers provide ideal markets. And when I say ideal, there were lots of ways in which this was very much not an ideal market. It was very, very difficult, but perhaps because it was so challenging, and especially because it was so price sensitive. And remember, these woolens are being imported all the way to China. There's huge costs added on by the transport. There's huge costs added on once they've left Canton and they start traveling up to cities in China. And they're competing with domestically produced Chinese fabrics, which are far, far cheaper. So it's a very, very tough kind of sale, and that makes them a great test ground. So I'm still working my way through the voluminous East India Company archives, but as far as I can see, lac dye is not mentioned in the China-related archives until 1820. And there, the Court of Directors note that they've dyed a subset of the broadcloth orders using the lac dye instead of cochineal because it is more permanent and it's also cheaper, and they've consigned cloths to Canton. And in response, the supercargoes, who are the ones actually based in Canton, express a deep concern that the Chinese would reject it as they, and here it's the Hong merchants who they're really dealing with, more approve scarlets professing a brilliancy and brightness of colour, which from the information obtained in these paragraphs, these will not. And lo, in 1822, they report back that the experimental consignment of broadcloth dyed with lac dye in lieu of cochineal has failed. Although possibly more durable in colour, the merchants have complained that they were inferior in richness and brilliancy of colour, and they had to sell them at a lower price. And they advised the Court of Directors not to include them again. The Court of Directors, and this is fairly typical, do not seem to have taken much notice of the supercargoes, and although possibly inferior in richness and brilliancy of colour, it seems to have been good enough for most purposes and was considerably cheaper. And so lac dye takes hold amongst the China market. There's also one more possibility that I should mention, a further motivating factor, which isn't really connected with China, but there's one respect in which lac dye is unlike cochineal, and it would be wonderful to hear Mila's thoughts on this as well. But my understanding is that it doesn't take on blue tones from adding an alkali, and so it cannot produce pinks or crimsons. And this is positive, and this may be wrong, but it seems to be, in terms of military purposes, droppings of water from iron did not affect the scarlet, whereas it did discolor a cochineal dyed cloth, and that was a big problem for cochineal dyed scarlets used by the redcoats of the British Army. And so lac dye becomes very popular for the military because it doesn't discolor from these droppings of water from iron, and so it's being imported in quite high quantities and used for this, and as a result, the price falls even further. So ironically, around the same time that lac dye becomes a viable dye, the cochineal monopoly of the Mexican province of Oaxaca collapses when Spanish colonial rule ends around 1820, and then you have surging production of cochineal in the Canary Islands and Guatemala, and this further marks the end of Mexican cochineal's high prices. For centuries, scarlet textiles had represented luxury and wealth, but the 19th century was to see the costs of the dyes that produce such bright colours fall massively, presaging the fall in consumer costs of colourful fabrics that was enabled by William Perkins' invention of aniline dyes. But the development of lac dye reminds us that in addition to these more acclaimed figures, there were many other unsung individuals involved in these processes, and their successes and failures also made a contribution, partly because of the constellating force that was represented by the East India Company and the way this unique institution served to connect dyers, chemists, merchants, markets, and consumers. Thank you.